Hey everyone, my name is Jackie. I work on marketing science, measurement, experimentation, and causal inference. On this channel, I share practical walkthroughs on how to use data science not just to analyze results, but to make better business decisions. Today, I want to walk through a very practical problems in A/B testing and causal inference. What do we do when the average treatment effect is not enough? In many experimentations, we started with one question. Does the treatment works on average? But in real marketing and product decisions, the next question is often more important. Does it work better for some groups than others? That is where the heterogeneous effect, subgroup analysis, and interaction tests come in. So in this notebook, I'm going to use a real randomized email marketing experimentation. Customers were randomly assigned to receive no emails, men's email, woman's email, okay? And in this walkthrough, for the simplicity, okay, I combine two email groups into one treatment, any email versus no email. For the outcomes, I will focus on the spend in the next 2 weeks after the experimentations. And look at this data set, okay? Before we jump into the analysis, let me explain the business context of this data set. This is a email marketing campaign from a e-commerce company. The company had a customer base with historical purchase information, and it wanted to know whether sending a promotion email would drive more customer activities or purchase. Each row in the dataset is for one customer. For each customer, we have some information such as recency, the historical spend, whether they had bought men's products or women's products, what is their zip code, whether they were a new customer, and what is their channel, what's their segmentation, did they visit the website, did they make a conversion, and how much they spent, okay? We have the randomized experimentation assignment. Some customers may receive the email. Some of the customer may not receive the email. So after the email assignment, the company measure the outcomes over the next 2 weeks. Whether the customer visit the website, whether they converted 0 or 1, how much they spend. Okay, this setup is very important. The customer history variables are all the pre-treatment features. The email assignment is the treatment, and the spend, visit, conversion are all the post-treatment outcomes, which we typically call the metrics. So for this walkthrough, I simplify the experimentation into a binary A/B test, any email versus no email. So let us focus on the main causal question. What is the incremental effect of sending an email? So the first thing I would like to walk you through is always look at the overall experimentation results. Let's look at it together. Because this is a randomized experiment, a simple difference in means gives us a valid estimate of the average treatment effect. Right here, the table compares the average spend, conversions, visit rate for no email and any email mean. The spend effect is positive, 0.5968. Okay. The customer, which means the customer who receives an email spend more on average than the customer who did not receive an email. And this is very useful, okay? But it is only the average effect. And the real business question usually come in a more nuance. If the email works on average, should we send it to everyone? Or are there some customer groups where it might work even better? And that's the next section I like to walk you through, which is the subgroup effects. So, for example, some customers historically bought men's products, some bought women's products, and some may bought both. Okay, so this results table answer a simple question. Within each subgroup, what is the difference between the email group and a non-email group? For example, when we look at the bought both group, right? And we notice that the effect is positive and the p-value is less than 0.05. Okay, but here is most people often made the mistakes. Okay, and this is most important part of this video. And think about what I'm going to say in the next few seconds. If several subgroups effects are positive or statistically significant, right? It is tempting to say those groups respond differently. But that is not what this table proves. This table only tells us whether emails appears to work within each group. Bought both, men's only, women's only. It only tells within each group with email versus no email, is any statistical significant or not. Okay, if we want to ask a question, which subgroup across the subgroup, how different they are. To answer that, we will need an interaction test. And I think I also introduced this concept in my last video. I now use a ice cream sale for example. So the interaction test asks a very different question. Okay, instead of asking does email work inside in the subgroup, instead it asks is email effect different between the different subgroups in the regression forms. Okay, we model the outcomes as the function of treatment subgroup and treatment times the subgroup. The interaction term is the important pieces. It represents the difference between two treatment effects. So if one subgroup has a spend left of $1 and another has a spend of 50 cents, the interaction is the difference between those two effects. And that is the real heterogeneity question. Okay, so for the time of the sake, let's jump into one example. Okay, so let's try to understand the prior category subgroup. Okay, so how are we going to read this table? Okay, in the prior category example, the subgroup effect looks positive. But when we run the joint interaction tests, the p-value right here, the both p-value does not provide a strong evidence that these subgroup effects are truly different from each other. And this is the key lesson. Subgroup differences is not the same thing as the treatment effect heterogeneity. For example, right here, the p-value, the interaction p-value is 0.3143. This means that if there were truly no difference in the email left between men only versus both customer, we would only expect to see a difference this large or larger about 31% of the time due to a random sampling noise. Okay, a subgroup can have a significant treatment effect, while the difference between the subgroups is still not statistically significantly reliable. That is, the distinction is extremely important in experimentation readouts. And let's look at another example too. Okay, and this is a more clear example. Here, the spend left for newbies is larger than the spend left for returning customers. So the interaction results give us the evidence that the treatment effect differs between these two groups. But even here, we should be also very careful. The conclusion is not simplified. Although the p-value is below 0.05, so we should automatically personalize. This is not a very good conclusion to the stakeholder. A better conclusion should be newbies appear to have a larger incremental spend response to email. So they may be a higher priority audience. So if we explaining to a more technical stakeholder, right? So we can say, compared to the newbie customer, returning customer have an estimated email effect that is about interaction versus reference versus about $0.5 lower. Okay, the interaction p-value is about 0.0265, which is lower than the 0.05. So we have the evidence that the email effect differs between the newbie and returning customers. And we can also plot some chart to the stakeholder as well. So finally, let's wrap up this video. Now we translate the statistical results into a business decision. The first thing I want to look at is the effect size. Okay, does that make business sense? Does that make a real dollar impact. How large is the spend lift? Then I want to look at the confidence interval. Is the estimate precise enough to act on? Then I want to also look at how we're going to translate the spend into the profit, right? So for example, email is cheap, but it is not free. So there's a direct sending cost, and there's also a customer attention cost. So in this notebook, okay, I use a very simple assumption: 1 cent per email and 45-cent gross margin. So under those assumptions, newbies have a stronger expected profit per customer. But we still need to check some guardrails. Okay, so the data sets already give us some conversion and visit rate, but it does not include any, for example, unsubscribes, spam, complaints, even long-term retentions. So in a real company, I really want those metrics before making a permanent rollout decision. And one more, there's also some opportunity cost. If we only send to newbies, we may give up some positive lift from the returning customer as well, right? So that's why we also need to consider the email capacity, frequency caps, customer attention are also may be constrained. So cool. So let me wrap up this video quickly. So what's the takeaway today? So the main takeaway is this: average treatment effects tell us whether something works on average. However, the interaction tests help us understanding whether it works differently across groups. So for a senior or a staff data scientist level, the readout should be not only stop at the p-values. It should connect the causal estimates to decision quality, effect size, confidence intervals, business value, guardrails, and operational constraints. And that is the difference between running an A/B testing and making a better business decision. I'm Jackie Yuan. If you like the video, please thumb up. And if you have a question, leave the comment. Thank you so much. I'll see you next time.